Hello, this is FlippedHarber for Precalculus, and in this video we're going to talk about section 6.3, double angle and half angle formulas. The objectives for this lesson are to use double angle formulas to find exact values, use double angle and half angle formulas to establish identities, and use half angle formulas to find exact values. The outline for this video will start by talking about double angle formulas. We'll talk about some other variations of double angle formulas. We'll use some double angle formulas to establish an identity. Then we'll move on to half angle formulas and find some exact values using half angle formulas. So, here's our double angle formulas. Now would be a good time to use that pause button in the corner so that you can write these down. Go ahead, push it, push it, push it. Okay. Moving on, hopefully you push the pause button and copy them down because you don't have time now. Here's some other variations of the double angle formulas. Now you can see here that this gives us a way to change a sine squared, a cosine squared, or a tangent squared into a double angle. So now this kind of raises another possibility for us. Usually when we see a trig function squared, we automatically think, oh, I'm going to use one of the Pythagorean identities. Well, take a look at the other side of that identity you're trying to establish. Maybe you want to use one of these. Go ahead and write these down now. Okay, I hope you wrote them down. So let's go ahead and establish this identity. Now really our process doesn't change a bit, except for maybe you want to look at this and go, well, the right side looks more complicated. But we're trying to use these double angle formulas, so we're going to stick with the left side. We're going to work on the left side of this identity and make it look like the right side. Really, 99 times out of 100 with this book, you're going to work on the left side. Alright, so let's take a look at the first thing we're going to do. I'm going to change it to a tangent on the left side because if you remember, if you pushed the pause button and you wrote those down, there was no cotangent double angle function. So we need to change it to a tangent in order to use one of our equations. Now we go ahead and substitute what the tangent to theta is equal to, but remember this is 1 over the tangent. So we take that double angle formula and stand it on its head. Okay, so now we need to work on this left side, and what we're going to do is separate it out into two fractions. 1 over the 2 tangent theta minus the tangent squared over the 2 tangent theta. I know that's kind of opposite one of the things that I told you to do, which was to combine fractions, but hey, look across the equal sign. We don't have fractions except for that 1/2. We have two things separated by a minus sign. Well, now on the left side I've got two things separated by a minus sign. So I'm going to go ahead and change that 1 over 2 tangent theta into a 1/2 cotangent theta. In the other fraction I'm just going to cancel because I've got tangent squared on top and I've got tangent on bottom. I can cancel a tangent, top and bottom. And there we are. Really all that's left to do is to factor out that 1/2. Okay, so let's take a look at some half angle formulas. So we use these when our angle is being divided by 2, obviously. So that's the sine of an angle divided by 2. That's not the sine of an angle and then the whole thing divided by 2. The angle is being divided by 2. Go ahead, push the pause button, and write these down. Alright, well I hope you did, because we're moving on. Okay, so here's a couple half angle formulas just for tangent. Now really, if you look at that bottom one, that's actually 2 equations built into one. So the tangent of alpha over 2 has 3 possibilities. How do you choose? Well, if you're trying to establish an identity, look at the other side of your equal sign. That's going to guide you which one of these 3 we're going to set it equal to. Alright, it'd be a good idea to push the pause button again and write these down. Alright, I hope you did, because we're moving on. And what we're going to do is we're going to find the exact value of cosine of theta over 2 given that tangent theta is equal to 4/3. Now, not a big deal to find cosine of theta if we know the tangent of theta. You did that back in chapter 5. I could give you the tangent of theta is equal to 4/3 and ask you what are the other 5 trig functions, and you should be able to do that. And this interval, pi is less than theta is less than 3 pi over 2, that tells you what quadrant we're in, quadrant 3 by the way, so that tells you whether each trig function is positive or negative. So I'm going to use my cosine of alpha over 2. I've got it theta and alpha, so that's kind of weird, but hey, deal with it. And what I need to do is go ahead and find out what this cosine is equal to, and that's what I need to do here. Use this tangent information to figure out what this bad boy is right here. So, pretty easy to figure out that this cosine is equal to negative 3/5. It's negative because it's in the third quadrant. I did the whole triangle trick and I figured out that it's 3/5. Okay, now this equation doesn't tell me whether to use positive or negative. So that's something we're going to have to deal with in a little bit. But let's do some simplification first. 1 minus 3/5 is 2/5. And since I'm dividing by 2, I can turn it into the square root of 1/5. Okay, now that I've got it all reduced, now I've got to make this decision. Is cosine theta over 2 positive or negative? Now, don't instantly say negative. Theta is in the third quadrant, but theta over 2 might not be. I need to figure out where theta over 2 is, given that theta is in the third quadrant. So, let's take these two limits of this interval and divide by 2, because if theta is between pi and 3 pi over 2, that means that half of theta is between pi over 2 and 3 pi over 4. Now this is not an entire quadrant. This is the beginning of quadrant 2. This is halfway through it. So is cosine positive or negative starting at pi over 2 and ending at 3 pi over 2? Well, it's actually negative. But I've got to go through this process to figure out if my theta over 2 is going to make my cosine positive or negative. Now you also need to do this when you're using double angle formulas. You need to pay attention to where theta is and then figure out where 2 theta is to make that decision whether it's positive or negative. Okay, that's it. I hope you wrote all those down. If you didn't, I guess I'd suggest that you back up and write them down now. All right, so get started on that homework. I'll see you in class and I'll see you online.